Welcome to our deep dive today.
Oh, yeah.
We're exploring the fascinating world of Quantum Generative Adversarial Networks,
Okay.
or QGANs
Yeah.
for short.
Yeah.
We'll be drawing our insights from an essay by Yorgo Schneepat titled QGANs, Quantum Generative Adversarial Networks for KI,
Yeah.
which really unpacks this emerging technology.
Right.
It's a mouthful, I know,
Yeah.
but trust me,
Yeah.
the concept itself is incredibly cool.
What's captivating about QGANs is their potential to revolutionize how we generate data, solve complex problems, and even push the boundaries of creativity.
Right.
Imagine a computer that could design life-saving drugs,
Wow.
create hyper-realistic simulations of financial markets,
Oh.
or even compose symphonies that rival the great masters.
That's a pretty mind-blowing thought.
It is.
Schneepat's essay jumps right into the heart of the matter, highlighting how QGANs combine two powerful concepts,
Right.
quantum computing
Yeah.
and generative adversarial networks, or GANs.
Yeah.
Let's unpack that a bit.
Okay.
For our listeners who might not be familiar,
Sure.
can you give us a quick rundown of what makes GANs so special?
Absolutely.
Okay.
Imagine two neural networks locked in a constant duel.
Um,
You have a generator, which creates data,
Yeah.
like an image or a piece of music,
Right?
and then you have a discriminator,
Okay.
which judges the authenticity of that creation.
Uh-huh.
It's like a game of cat and mouse,
Yeah.
where the generator is constantly trying to outsmart the discriminator with more and more realistic outputs.
So as this duel goes on,
Right.
both the generator and discriminator get better and better at their jobs.
Precisely.
Okay.
The generator becomes increasingly skilled at creating realistic data,
Uh-huh.
while the discriminator becomes more adept at spotting fakes.
Okay.
This constant feedback loop pushes both networks to improve,
Uh-huh.
leading to incredibly sophisticated outputs. Think about the realistic deepfakes you've probably seen online.
Oh, yeah.
That's a prime example of how powerful GANs can be.
Okay.
Yeah?
So we have these creative GANs on one side.
Right.
Now let's bring in the quantum element.
Okay.
What are some of the key aspects of quantum computing that make QGANs so different from their classical counterparts?
One of the most significant differences lies in the way quantum computers process information. Instead of bits, which are like tiny switches that can be either on or off,
Right.
quantum computers use qubits.
Okay.
Qubits can exist in a state of superposition, meaning they can be both 0 and 1 simultaneously.
Okay.
This allows quantum computers to explore a vast number of possibilities at the same time, giving them a huge advantage for certain types of calculations.
It's like they're playing a game of chess where they can consider every possible move simultaneously.
Exactly.
That's incredible.
Yeah.
But how does this quantum weirdness actually play out in a QGAN?
Whoa. Imagine the generator in a GAN being replaced by a quantum computer.
Oh.
This quantum generator, thanks to superposition,
Right.
can explore a massive space of potential outputs in parallel.
Wow.
Something that would be impossible for a classical computer to do.
Okay.
It's like having a team of ardents working on the same masterpiece at the same time,
Yeah.
each contributing their unique perspective.
I see.
This allows QGANs to generate data with a level of complexity and nuance that we've never seen before.
So in essence, we're
Yeah.
taking the creative power of GANs
Right.
and amplifying it exponentially
Exactly.
with the mind-boggling abilities of quantum computers.
That's a great way to put it.
Okay.
The potential is truly remarkable.
Yeah.
Schneepat's essay delves into some specific applications
Okay.
where QGANs could have a transformative impact. For instance,
Yeah.
he discusses how QGANs could revolutionize drug discovery
Wow.
by simulating molecular interactions with unprecedented accuracy.
That sounds like a game changer for the pharmaceutical industry.
Absolutely.
Schneepat also mentions some fascinating applications in image analysis, right?
Absolutely.
Okay.
He talks about how QGANs could be used to enhance images, making them incredibly detailed and precise.
Right.
Imagine using this in medical imaging
Yeah.
to detect subtle anomalies that might be invisible to the human eye,
Okay.
or using it in satellite imagery to identify patterns and trends that could help us understand climate change better.
These applications are incredible.
They are.
And it feels like we're just scratching the surface of what QGANs can do.
Yeah.
But surely with a technology this advanced,
Right. Yeah.
there must be some challenges along the way.
Of course.
What are some of the hurdles
Yeah.
that researchers are facing
Yeah.
in developing and implementing QGANs?
One of the biggest challenges is the current state of quantum computing hardware.
Okay.
We're still in the early stages, and quantum computers are notoriously delicate and prone to errors.
Mm-hmm.
Building and maintaining a stable quantum computer with a large number of qubits is a major hurdle.
It sounds like a delicate balancing act.
It is.
Trying to harness the power of quantum mechanics while dealing with these limitations.
Yeah.
Are there other challenges besides the hardware itself?
Another major challenge lies in developing the algorithms needed to train QGANs effectively.
Right.
These algorithms need to work seamlessly across both classical and quantum computing platforms, which adds a layer of complexity.
Yeah.
Schneepat mentions a specific problem called barren plateaus, where the landscape of the problem becomes very flat.
Oh, I see.
Making it extremely difficult to train the QGAN effectively.
Yeah. So it's like trying to find a needle in a haystack.
Right.
But the haystack is constantly shifting and changing shape.
Yeah.
It definitely sounds like a formidable task.
It is.
But before we dive deeper into those challenges, let's take a closer look at some of the most promising applications of QGANs.
This is good.
Where does Schneepat see this technology making the biggest impact in the near future?
Well...
Yeah. Welcome back to our deep dive into the world of QGANs. Before we went on that little tangent, we were discussing the mind-blowing potential of this technology.
Absolutely.
As well as some of the technical hurdles that need to be overcome.
Yeah.
Jorgo Schneepat's essay outlines some really exciting possibilities for QGANs.
Right.
Particularly in fields like finance and materials science.
Yeah.
Let's start with finance.
Okay.
How could QGANs potentially revolutionize the way we understand and manage financial risk?
It's fascinating to consider the possibilities.
Yeah.
Imagine using a QGAN to create hyper-realistic simulations of financial markets.
Yeah.
These simulations could capture complex interactions and dependencies that are simply beyond the capabilities of classical models with this level of insight. We could potentially predict market crashes.
Wow.
Identify emerging trends, and even develop more effective risk management strategies.
That sounds like a dream come true for any investor.
It would be amazing.
But how would this work in practice?
Well,
yeah. What makes QGANs particularly suited to tackling these complex financial problems?
It comes down to the QGAN's ability to model probabilities and uncertainties with incredible precision. Quantum computers excel at handling probabilities thanks to the concept of superposition, where a qubit can exist in multiple states at once.
Yeah.
This allows QGANs to explore a vast range of potential outcomes simultaneously, giving us a much more nuanced and accurate picture of financial risk.
So instead of relying on historical data and traditional models, we could use QGANs to generate scenarios that account for a wider range of possibilities, including those black swan events that catch everyone off guard.
Exactly. It's about moving beyond simple predictions and developing a deeper understanding of the underlying dynamics of financial systems.
Right.
QGANs could help us identify vulnerabilities, assess the potential impact of policy changes, and even develop more robust and resilient financial instruments.
It's incredible to think that we might one day be able to anticipate and mitigate financial crises. With the help of quantum computers.
Exactly.
But Schneepat doesn't stop there.
He doesn't.
He also sees QGANs playing a significant role in material science.
Yeah.
Can you tell us more about that?
Material science is all about understanding the properties of materials at the atomic and molecular level.
Okay.
This involves grappling with complex quantum interactions that are incredibly difficult to simulate using classical computers. However, quantum computers and, by extension, QGANs are perfectly suited to tackle these challenges.
QGANs could help us design entirely new materials with properties that we can't even imagine today.
Precisely. Imagine being able to simulate the behavior of exotic materials like superconductors at room temperature. Something that has been a holy grail for physicists for decades. Or designing materials that are lighter, stronger, and more durable than anything we have today.
Wow.
The possibilities are truly endless.
This all sounds incredible.
It is.
But let's come back down to earth for a moment. Before we can unlock these amazing possibilities, we need to overcome some pretty significant challenges.
Absolutely.
As we discussed earlier, the limitations of current quantum hardware are a major hurdle.
They are.
We need more stable and scalable quantum computers before we can truly unleash the power of QGANs.
Yeah.
And developing the algorithms needed to train these hybrid systems is another complex challenge.
It is.
Schneppat's essay doesn't shy away from these challenges.
Right.
He seems optimistic about the future, but also acknowledges that there's a lot of work to be done.
Yeah.
Where do you see the field of QGANs heading in the next few years? What are the key milestones we should be looking out for?
I think the next few years will be crucial for QGAN development.
Okay.
We're likely to see significant progress on the hardware front.
Yeah.
With more powerful and reliable quantum computers becoming available.
Right.
On the software side, researchers are developing new algorithms and techniques to train QGANs more efficiently and effectively.
So we're still in the early stages.
Yeah.
But the pace of innovation is accelerating.
Absolutely.
It's an exciting time to be following this field.
It is.
But before we get too carried away with the future, let's bring the focus back to the present.
Sounds good.
What are some of the key takeaways from Schneppat's essay that our listeners can apply to their understanding of QGANs today?
Wow.
Welcome back to the final part of our deep dive into QGANs.
Yeah.
We've covered a lot of ground.
We have.
From the fundamental principles of QGANs to their mind-boggling potential applications. Now let's synthesize what we've learned.
Okay.
And distill some key takeaways from Jorgo Schneppat's insightful essay.
Sure.
What are the core ideas that our listeners should walk away with?
One of the most important takeaways is the sheer transformative power of QGANs.
Yeah.
We're talking about a technology that could revolutionize fields as diverse as medicine, finance, and material science.
Yeah.
The ability to generate and manipulate data with this level of complexity and precision is truly unprecedented.
It feels like we're on the cusp of a new era of scientific discovery and technological innovation.
It does.
But Schneppat also cautions us to approach this new frontier with a sense of responsibility, right?
Absolutely.
Yeah.
As with any powerful technology, there are potential risks and ethical considerations that we need to address.
No.
While the essay doesn't delve deeply into these aspects, it does underscore the importance of responsible development and deployment of QGANs.
It's a reminder that we need to be mindful of the potential consequences of our creations.
Absolutely.
Even as we celebrate their incredible potential.
Yeah.
What other key insights from Schneppat's essay stood out to you?
One thing that struck me was his emphasis on the need for interdisciplinary collaboration.
Okay.
Developing and harnessing the power of QGANs requires expertise in fields like quantum computing, artificial intelligence, and domain-specific knowledge in areas like finance or medicine.
Yeah.
It's a call for researchers, engineers, and domain experts to come together and push the boundaries of what's possible.
It highlights the fact that innovation often happens at the intersection of different disciplines.
It does.
So for our listeners who are intrigued by QGANs and want to learn more, where would you recommend they start?
Schneppat's essay is an excellent starting point, of course.
Okay.
Beyond that, there are numerous online resources, research papers, and even open source software platforms that allow you to explore the world of quantum computing and GANs.
That's really cool.
It is.
The key is to stay curious.
Absolutely.
Embrace the challenge of learning something new and never stop asking questions.
Those are wise words.
It's clear that QGANs are a rapidly evolving field with immense potential.
Yes.
As Schneppat's essay so eloquently demonstrates, we're just beginning to explore the possibilities of this exciting new technology.
Yeah, we are.
A huge thank you to Jorgo Schneppat for providing such a thought-provoking glimpse into the future of QGANs.
You did a great job.
And thanks to all of you for joining us on this deep dive.
It was fun.
Until next time,
keep
exploring and stay curious.
Always.